Alright, hi everyone. So since a lot of you struggled with the Section 6.1 formative assessment, Mr. Ravens and I decided we were going to make a video real quick going through all of these questions to kind of help clarify some of these things for you. So for questions 1 through 4, I think the biggest problem my students had is you didn't read the directions. So it says determine whether the figure is a polygon or not. If it is a polygon, classify it by its number of sides. And if it's not, you have to explain why not. So each of these lines should still have something written on it. All right, so for question 1, the answer was no. You have to remember that a polygon needs to be a closed figure, and the sides of the polygon, those segments, have to only meet at the end points. Well, we can clearly see that these sides are crossing at more than just the end points. They're crossing at all of these points on the inside here, and that makes it not a polygon. So for my students, I let you guys just kind of write that it crosses too much or that it overlaps. I'm not exactly sure what Mr. Ravens has you guys write, but probably something along the lines of segments cross at more than the end points. At more points than just the end points. But as long as you can get something along those lines out for us, we know what you mean. All right, figure 2 is a polygon. It's made up completely of segments. It's a closed figure. All of the segments are meeting at the endpoints, and so what we need to do then is classify it by its number of sides. So I always put a mark on the side that I start with, and then I go clockwise so that I make sure I count all the sides. So 1, 2, 3, 4, 5. So since n is 5, we know that that is a pentagon. Don't just write 5 sides or n equals 5. You have to tell us the name of the polygon. You have to classify it. All right, figure 3 you guys should be able to look at very easily and tell us that yes, that is definitely a polygon, and that one has 1, 2, 3, 4, 5, 6, 7, 8 sides, which means that is an octagon. It's like a stop sign. And for figure 4, this is not a polygon. This part right here is curved. Polygons have to be made up completely of segments. And so because that is curved, that is not a polygon. All right, moving on, we're going to determine whether the polygon is regular or irregular and state whether it is concave or convex. Well, we have to remember that a regular polygon means that it is equilateral and equiangular, meaning all the sides and all the angles are congruent. All right, and we also have to remember that if a figure is regular, if a polygon, there we go, thank you, I could not think of the word, polygon is regular, then we know that it is going to be convex. All right, so those two always go together. So when we take a look at figure 5, we can see all 3 sides are congruent and all 3 angles are marked congruent. So it is equilateral and equiangular, which means that this polygon is regular. All right, and we just said that if it's regular, we know it has to be convex. For question 6, if we look, we've got 4 of these sides marked congruent, but the 5th side here is this one along the bottom, and it's not marked congruent, which means this figure is irregular because it is not equilateral. And then when we look at whether it's concave or convex, we can see that the figure is kind of coming in on itself right here. So this is concave. We can also look at it and see that if we were to draw a diagonal from this vertex to this one, that diagonal would be outside the figure, and that also helps us determine that it is concave. For figure 7, if we look, we've got a bunch of congruent segments here, but these 2 segments have their own markings, and since they're not all completely the same, it is not regular, it is irregular. But when we look at this figure, no part of it is really going inside of itself. If we were to draw any diagonal inside of this figure, or I'm sorry, any diagonal for this figure, they would all end up being inside. So this figure is convex also. All right, moving on, if we look at the back, this is where a lot of my students started to struggle. And I think part of it is you guys just aren't sure which formulas to use. So for question 8, it says find the sum of the interior angle measures of an octagon. So first of all, I'm going to underline sum of the interior angle measures. And before I even do anything, I'm going to write the formula that I need. So I know that the sum of the interior is always equal to n minus 2 times 180. So now what I need to do is I need to figure out what an octagon is. So you guys should know by looking at this that octagon means that n equals 8. It's like a stop sign, all right? It's a polygon with 8 sides. So if I want the sum of the interior, that's going to equal 8 minus 2 times 180. So 6 times 180, which means we get that the sum is equal to 1080 degrees. All right, it didn't ask for each angle. It's not a regular octagon, so you have to be careful because I had a number of students that then divided this by 8, or some divided it by 6. So be careful, all right? Make sure that you are giving us the answer that we asked for. Question 9. So we're finding the value of x, and when we look at this figure, x is an angle inside of this polygon. All right, so you should be able to look at this polygon and know that it is a pentagon because there are 5 sides. And when we look at this, we're given 4 of the angles inside of the pentagon, and we're looking for the 5th. So what that means is this is kind of a two-part question. All right, so the first part that you're going to have to do before we can even start to solve for x, your first step is going to be find the sum of the interior. All right, so we know that the sum is going to equal n minus 2 times 180, and we know n is 5, so 5 minus 2 times 180. So the sum is going to equal 540 degrees. Okay? Now we can start to use the other information that we have. We know that all of these angles are inside, so if I add them all up, it has to equal 540. So x plus 118 plus 100 plus another 100 plus 124 has to equal 540. And if we combine like terms, we get x plus 442 is equal to 540. And then we just need to subtract the 442 from both sides. So we get that x is equal to 98. So that is our answer for question 9. This was kind of the start of our step 2. Sorry, I forgot to write that. So step 1 is find the sum of the interior angles, and then step 2 is use all the angles inside and set it equal to that sum that you found in step 1. All right. Question 10 says name the convex polygon whose interior angle measures have a sum of 900. Well, the interior angle measures have a sum of 900. We know that the sum of the interior angles is equal to n minus 2 times 180. All right, so what that means, this sum of the interior angles is 900. So I can just go ahead and say 900 is equal to n minus 2 times 180. Now, there are a couple different ways for you to solve it. Whatever algebra method sticks out at you is fine. I'm going to go ahead and divide both sides by 180. So I get that 5 is equal to n minus 2. And then I'm going to add 2 to both sides, and I get that 7 is equal to n, which means this is a polygon with 7 sides. And be careful, because we didn't just ask you to find n, we said name the polygon. So we know that if a polygon has 7 sides, it is called a heptagon. All right, I'm going to show you guys just really quickly the other way to solve this if you wanted. So you'd have 900 is equal to n minus 2 times 180. So if you want, you can go ahead and distribute the 180 to both sides. So we get 900 is equal to 180n minus 360. And then you can just add 360 and divide by 180. So either one of these methods will work, and you'll still get to n equals 7, which will still get you an answer of heptagon overall. Okay? Moving on to question 11, find the measure of each exterior angle in a regular hexagon. So each exterior angle, and we can see that this is a regular hexagon. All right, so first things first, hexagon, I'm going to go ahead and write n equals 6 because I know that hexagons have 6 sides, and I want each exterior angle. So this is one of the formulas that we wrote down. So 360 over n is going to equal the measure of one exterior angle of a regular polygon. All right, I know that for my students at least, we wrote down all of our formulas in the back of our packet. This was one of them. Okay, so each exterior, the reason we chose 360 was because the sum of the exterior angles is 360. And since it's a regular hexagon, we want to divide by the number of sides because they all have to be equal. So for this one, it's just 360 over 6. And so we get that the measure of each angle is 60 degrees. And that's it. Okay. Number 12, the measure of one exterior angle of a polygon is 30 degrees. How many sides does the polygon have? So again, we're going to use that same formula we just used in number 11 because we have the measure of one exterior angle. All right, and we're going to actually, I'm going to put a note in here that this needs to be a regular polygon. All right, so the measure of one exterior angle of a regular polygon is 30 degrees. How many sides does the polygon have? So we're just going to do 360 over n is equal to the measure of one angle. Okay, and so we get that 360 over n is equal to 30. And so what I keep telling my students to do is make this over 1, and we're going to cross multiply. So we're going to end up getting 360 is equal to 30n. And then we can divide both sides by 30, and we get that n is equal to 12. So there are 12 sides on this polygon. All right, hopefully that makes a little bit more sense. Feel free to rewind, to rewatch certain parts if you need to, or make sure you get into the Math Resource Center and get some help if you need it. All right, thanks for watching.